Well, then, it's been an interesting 24 hours, and it's been an interesting half an hour, in fact, as we saw the first M-class flare in quite a long time while we did show prep today. We'll be talking about all kinds of sweet things going on, coronal mass ejections, major filament eruptions. This slow motion's pretty sweet, and thanks for tuning into the Smash News Network least busted name in news. Here's a little closer view. Now, we've slowed this down to 5 frames per second, but we're actually playing it at 2 times speed, so it's technically 10 frames per second. And that's a pretty good slow-mo breakdown there of a solar flare and a coronal mass ejection in SDO 335 angstroms. Let's let that play through one more time for your viewing pleasure. So that's a good one. And it might look even better in some other wavelengths. Here's 211 plus 171 angstroms, different species of ionized iron from SDO. As different portions of the solar corona are highlighted by these wavelengths. 211 angstroms shows the extended corona. 171 angstroms shows the lower corona. Here's 304 angstroms ionized helium. And this might be the best of all. By the way, the recent M-class flare did come out of this active region as well. There's a great nearly circular solar flare happening there. Quite low in the corona. We'll let that one play through again, as that is certainly some pretty sweet footage. And that is only actually 2 hours from this morning. So that's 5 to 7 Universal Time this morning on June 16th. Here's a full 24-hour video, which is what we're usually showing on the channel. We just slowed that one down for aesthetics. Yes. So plenty of stuff going on here. A little bit of a solar uptick on the sun side and a space weather uptick on the earth side, as we've had geomagnetic storm conditions. Pretty much exactly what we forecasted on the channel, as we laugh and laugh at the, quote, competition, end quote, since there is no competition. Now, we have had some activity in the northwestern limb. It's not major. There were coronal mass ejections, which we'll get to, since there's one in the process of exiting the solar corona as we make the video. It happens regularly. There's the western equatorial view. And that coronal hole there, just to the east of the Earth scale, is what is causing the current geomagnetic storm and geomagnetic unrest conditions. It's a high-speed solar wind. It made it up over 700 kilometers per second, which is somewhere in the realm of 1.5 million miles per hour. To put it in context for you there in terms of automotive speeds, 700 kilometers per second is about 1.5 million miles per hour. Keep in mind, it is diffuse gas, so it's not the kind of an object like a car. If you were in space experiencing it yourself, you would experience it as radiation. Many of those particles would pass right through you. There's the Cornell West filament. Shout out to our Twitter followers. If you want to name filaments after living people, follow us over on Twitter and follow the hashtag #NameThatFilament. So this is the Cornell West filament right here, and this one down here ain't got no name. But there are certainly lots of filaments that could get names. Here's the sort of western equatorial view. As you can see there, we've got additional coronal holes rotating in here around the equator, which is why we stated that the coronal hole high-speed stream situation could last about 48 hours. It might be even longer than that. It might be like 72 hours, 96 hours. It could be quite a while here, as there are certainly strong fields associated with those coronal holes and quite high-speed plasma. Here's that active region. It's actually 3 active regions. Those are 3 separately named sunspot groups up there. And before we show some other imagery, let's take a look at sunspots briefly here from the SDO Browse Data section. That's the SDO continuum there. No big changes happening with sunspots here. No big changes. A little bit of growth. Well, let's see here. A little bit of growth happening up here in the northwest. So there's a new sunspot. That'll likely get a name today. Here are the magnetic fields, and you can see that sunspot popping up there. So it looks like we'll get at least 1 new named group today, maybe 2. In the northwest, besides that, not a lot of changes happening. And let's see what's going on planet Earth. By the way, we've got this great video of Kilauea here from 2 Pineapples. Go subscribe to their channel. They are the folks who've been videoing Kilauea. Imagery there. Some imagery of the Spatter Pineapples channel. The sounds and sights of the spatter cone above the Halema Uma'u lava lake there shorts at Kilauea. Lots of people have. YouTube.com/smashomash/shorts. So let's see what else is erupting here besides Kilauea. That's what the spatter cone looks like, that video from a few days ago. It's been remonetized, so we decided to actually show it and make it not private. So, what do we have here? This is Nishinoshima there, little tiny volcanic island there. Probably uninhabited, Nishinoshima. Some new aerial images of that. Frequent strong degassing and continuing venting of gas and steam from the summit crater. Yes. Sakurajima also erupted, produced a 7,000-foot ash plume, 5,000-foot ash plume from Subanose-jima. Mount Mayan continues to erupt in an elevated fashion. A viscous lava flow on the southern and southeastern slopes continue to be active. No indication on an ash plume there. And debris deposits reached a distance of about 2 kilometers from the summit. Lubatolo also exploding, flight level 070. It's a 7,000-foot ash plume. Semaru, 13,000-foot ash plume. As Semaru explodes, it's a flight level 130. Again, spatter cone continues to remain active at Kilauea. It's part of the Halema Uma'u lava lake system. Again, check out 2 Pineapples, who is putting up regular fantastic imagery there of Kilauea on the big island of Hawaii. Popocatépetl exploding, flight level 190 over central Mexico. 19,000-foot ash plume there. 15,000-foot ash plume over Fuego in Guatemala. Nevado del Ruiz. Reports of volcanic ash there in Colombia. Sabancaya exploding, flight level 240. It's a 24,000-foot ash plume. And Piton de la Fournaise on the Isle of Réunion. Increased seismic activity beneath the volcano there. The possibility of magma moving around in magma tubes could indicate an eruption about to happen. Interestingly enough, and related to our volcanic coverage, is today's featured merch item. You can find the Redbubble shop linked below this video in the description, as well as on our homepage at smashomash.com. It'll say Smasho Merch. That'll send you to the Redbubble shop as well. This is our top seller, the Do Not Pole Vault the Caldera public service message. Basically, if you're going through hell, keep going, as our finest days lie ahead. Yeah, it might seem like things are pretty bad right now, but ultimately, overall, on a sort of a global basis, things are actually kind of good on planet Earth. I mean, you might be worried about all kinds of economic strife and political strife and strife. You might even think that the galaxy's about to kill you. However, I'm here to tell you that our finest days lie ahead. So remember, folks, you got to plan to be alive, not to be dead. There is no plan for being dead. I understand things like life insurance are a thing. However, your real plan has to be alive. So, yeah. And thanks for leaving comments, General Disturbance. So in any case, do not pole vault the caldera. No matter how bad things seem, they can certainly get worse, but in fact, they'll get better. Seismic activity here at very high levels, as we saw a 7+ magnitude earthquake in the past 24 hours. It was in a spot where nobody probably felt it, plus it was at extreme depth. They're in between Tonga and New Zealand was the location of that 7.2 magnitude quake. It was at 167.4 kilometers estimated depth. So not only in the middle of the ocean there, but not around any populated land masses. So unlikely felt by anybody, that 7.2 magnitude quake. We'll talk about that as well as all the quakes of a 5 magnitude or higher. So that 7.2 came in at 18:06 Universal Time yesterday evening. 7.2 magnitude quake there near Tonga at 167.4 kilometers estimated depth. Only 61 minutes later, there was a 5.2 across the Pacific Ocean there on the coast of South America. That was a 5.2. So after that, an extended period of calm, making it look like perhaps that 7.2 was a foreshock, but fortunately it doesn't look like it was. The next quake on the list is a 5.0 at Bangladesh. That was at 4:46 Universal Time this morning. And then Tonga region started kicking back up again. So we had a 6.0 at 8:11 this morning, a 5.1 at 8:41, a 4.9, a 5.7. As you may expect, lots of aftershocks there following a quake of that magnitude. And let's get back to space, as there is plenty of action going on and plenty of action to come since we aren't even at solar maximum yet. I can't believe it's controversial to state facts on YouTube, but apparently it is. Yeah, we're not at solar maximum yet, and I guess that's going to make somebody mad because they're in a cult. That's why. So we're going to get to coronal holes and sunspots here. So let's talk about some space weather stats first, since we've got plenty of them that are interesting to say the least. The 10.7 centimeter radial flux is actually only at 151. I'll make it 153 solar flux units. There is the 1-year graph of the radial flux. It's the black line. As we are expecting a big breakout here. We've broken out repeatedly over the 155 level, as that seems to have been a support level for this black line here. You can see lots of change of direction there when it comes to about 155 solar flux units. So just about to probably break out of that again, as we've got some significantly active sunspot regions rising, especially the one in the northeast. So anyway, there's the NOAA forecast, and coming a little bit late to the game there. NOAA forecast and a KP6 for this morning. Yeah, a little bit late to the game. What can I say? If you've been watching our videos, you've probably noticed how accurate our forecast was for this coronal hole high-speed stream. Let us know in the comments if you agree or disagree with this statement. My feelings will not be hurt. I can guarantee you that. Next, the past 4 hours of Earth's magnetic moment from space. Since lots of people are on the internet getting paid hundreds of thousands or indeed millions of dollars per year to just straight up misrepresent science publications and tell you that Earth's magnetic poles are likely to flip soon, a completely ridiculous notion. There's Earth's magnetic moment from space for the past 4 hours. It looks perfectly healthy to me. That's the space weather modeling framework. Again, we've had geomagnetic storm conditions continuing for an extended period, and we're expecting this coronal hole high-speed stream to last a while, and there is going to be some sputtering continued increases. So this coronal hole high-speed stream is not anywhere near over yet. You can expect this to go on at least for another day, but possibly another 2 days or so. So these are the ground magnetic perturbations. This is where you can expect to see the aurora. This is geospace delta B. In other words, changes to Earth's B field in nanotesla, which is magnetic flux density. And when we do see times of heightened geomagnetic activity, we usually do show the North American view here, since most humans are in the northern hemisphere. These are some of the better places and more likely places for people to see the aurora, so we like to bring that to folks' attention. Anyway, that's the past 4 hours of ground magnetic perturbations over North America. You can use that to estimate where you might be able to see the aurora. I've used it myself and been surprised, actually, to see aurora in places like Pennsylvania when I didn't even expect to see them. And we've got videos about that on the channel as well. Here's the full globe view. This is going to show you, like the geospace Delta B map for North America, it'll show you where the telluric currents are likely to be located, where the aurora is most likely to be visible, also induction into the power grid and to pipelines and railways. So that's the past 4 hours of Earth's magnetic moment from the ground. And no, it's not showing quadrupoles. It's not showing Earth's magnetic poles flipping. It just isn't. So move on. Move on and do something interesting. Planetary K-index has made it all the way up to 6.33, which was, I believe, exactly what we forecasted on the channel. Go watch previous space weather videos to verify this. But there you go. Current conditions are KP 4.67. It's just this side of a G1 geomagnetic storm. Now, we forecasted that the solar wind density would make it to 26. It made it up to about 28. I'd say that's a pretty accurate forecast. What would you say? And the solar wind speed made it surprisingly high here, over 700 kilometers a second. So the peak density was around 28. The peak velocity was around 720. Make it 730. 726 is the highest reading that I see. 745. All right, so that is a significantly high-speed coronal hole wind stream. Although it's not very dense, solar wind density here, barely 2 protons per cubic centimeter. Solar wind speed currently at 647 kilometers per second. And as we forecasted about the GOES magnetometers, you can see those spiky, very sawtooth readings there. That is a plasma effect. GOES magnetometers there showing actually quite low highs and low lows here over the past 24 hours. Some big variations there as coronal hole high-speed stream impacts with a vengeance. Next, we'll look at the heliospheric current sheet. This top view ecliptic plane field plot depicts the solar plasma in polar form. Earth is right in the middle of a south pole current sheet. No sudden changes expected to happen there, although we do see some stuff happening over here in the east. So that could be an indication of a new sunspot about to rise or form in the south. So that's a forecast based on the top view ecliptic plane field plot. We may see a southern sunspot here about to rise or form in the southeast. Yeah, the southeast. So keep an eye on that. That's a forecast based on understanding how the data correlates. Here's our line of sight field plot, and Earth is right in the middle of a South Pole oriented current sheet, which is why you can see the blue portion of that imagery fanning out there. There are a bunch of solar radio jets oriented directly toward the Earth. They're known as coronal holes, the source of those coronal hole high-speed streams. There are coronal holes in our line-of-sight coronal hole plot. They are all of South Pole orientation. And here they are from SDO. So very well-defined South Pole-oriented coronal holes, and every single one of those visible on that image are of South Pole orientation. So it's time to move to sunspots next. There is the flare probability and solar flare scoreboard. Like I said earlier, we've got 3 sunspot groups up there in the northeast. 3338 is, I believe, the one that's been producing the major flares. So it will remain the most likely place to see major flares. Again, we saw the first M-class flare in quite a while happening while we started the show, which seems to be an ongoing theme. Perhaps it's the sun leaving comments for people like you. Anyway, here's the past 24 hours in SDO continuum. And again, we're expecting 2 new sunspot groups to be named up here in the northwest. There's 1, there's 2. And I think those are the only named sunspot groups, but we can expect a major uptick here in the radio flux and the sunspot number coming. Despite some groups sitting there in the west, we have more incoming space weather than we have outgoing space weather. It's a solar uptick. And if that's offensive to you, then I'm not sorry in the slightest, except that you've been believing a lot of nonsense on the internet about space, I'll just say. And if you think space is fake, please let us know in the comments that you think space is fake. That'll be fun. That'll be a fun YouTube comments argument. Or perhaps on BitChute. BitChute, the only place in the world where we find comments that are dumber than the comments on YouTube. If you've got an idiotic comment, please make sure you leave it. We will not mute or ban you in any way, so don't make a fool of yourself. Goes proton flux still flatlined here. No spikes despite the largest flare in quite some time happening here just as we produced the video. It was an M1 flare, an M1.06. So not a major flare, but we're going to show you some footage of that later. First, the last 24 hours. As that flare happened so recently, it did not appear on the video. So again, I believe that was from this group up here. Might not be 3338. I think it's 3337, actually. The farther north one is the one that's been producing the flares. There's the full disk view. And again, lots of activity going on here. Huge plasma filaments, the likelihood of coronal mass ejections, nearly 100% and so forth. Let's continue on. As we've got some additional space resources to share with you today. But before we do that, let's talk about our paid affiliates / sponsors. So one of them is Hemp Lucid. So thanks to Hemp Lucid and thanks to everybody who's picked up products through the Hemp Lucid shop. If you want to save 10% on your Hemp Lucid order, just enter the promo code SMASHOMASH on checkout and save 10%. You can shop via the links in our description as well as links on the homepage. You can find the Hemp Lucid symbol right there at smashomash.com. So don't forget to enter the promo code SMASHOMASH to save some dough on checkout. Whether you're picking up CBD tinctures, lip balms, mushroom gummies, etc., promo code SMASHOMASH saves you some dough even on your Delta 8s. The other affiliate link is to our Amazon shop. And today I'm actually wearing the featured product here, the Allemans and Gentle Hawaiian shirt. Yeah, I'm wearing it right now. So in the Spacewear collection, you can also find these glasses. They are polarized and they are not expensive. I'm a cheap sunglasses person as I destroy them on an annual basis. Sometimes even on a semi-annual basis. Anyway, you want to pick up some sweet Hawaiian shirts? I've been a collector of Hawaiian shirts for over 20 years, and let's get back to space. Yeah, spacewear. Don't go to space without your Hawaiian shirt. What kind of vacation would that be? This is what's going on overhead. You've got a sliver of a moon up there, quite close to Mercury. If you're up before dawn, you might see Saturn and Jupiter rising ahead of the sun. And if you're up shortly after dusk, you might be able to see the aurora tonight. But if you've got clear skies, you'll certainly be able to see Venus and Mars very close together on the ecliptic. So a great time to be looking up, especially in the early morning or the early evening. Now, like I said, we've got some additional space resources for you here. A lot of people think that the planets orbit the sun, and it's not really true. The sun and the planets, they orbit their common center of mass in the galaxy, which is known as the barycenter. And this leads to a lot of theories that don't seem to really pan out, where people say that Jupiter and Saturn cause earthquakes, they cause solar activity, and so forth. I won't get into the weeds on that. However, just keep in mind, folks, that the planets do not orbit the sun. The sun and the planets orbit each other. So just like a binary star system, they're actually orbiting their common center of gravity. There are some animations as to what the sun versus Jupiter's orbit will look like, depending on where you're looking at them from. So the barycenter, it's a common thing we hear when we talk about space weather. If you're not familiar with that, there's an article here from NASA's Space Place. What is a barycenter? That is the common center of mass around which everything in the solar system orbits, including the sun. Yeah, it wobbles back and forth like more than a solar radius. And thanks to Eugene Bagashov here, for also known as Eugene the Philosopher, by the way. Eugene the Philosopher on YouTube. Check out his channel. Subscribe if you haven't. We're trying to get to him. We're trying to get him to 1,000 subscribers. So if we find out that you're subscribed to our channel and not Eugene's, there will be repercussions. I can't say what they are. One of the visualizers of the barycenter is super interesting. It is Tychos.space. Yeah, Tychos.space. And you can actually calculate what's going on with the solar system. Let's make 1 second equal to a month here. Now, this is centered on the barycenter. So this is actually the sun's movement. You can see the Earth's orbit there. If we zoom out a little bit, there you can see Jupiter's orbit as well. And it might look weird because, again, this imagery is centered on the barycenter of the solar system, not on the sun. If you center it on the sun, it's a completely different scenario. There's the sun as the center. This is the actual center of the solar system, the barycenter, the common center of mass around which all of the planets orbit. It's Tychos.space if you want to make little animations of that. Tychos.space is a great tool. And also don't forget Plasmascape. So if you want to look at things from a cosmology perspective, interestingly enough, this is a model of the solar system here. And we've oriented the sky dome here. The sky dome, yeah. We've oriented that to be oriented towards Cygnus and Deneb, because that's actually where the local group of stars are moving. They're moving toward Deneb. And the sun is moving a little bit to the right with respect to those other stars. But the local interstellar group is all moving toward Deneb. And Plasmascape is what we use for this. And of course, you can zoom out to show other features here, such as the interstellar chimney. If you zoom all the way out to level 5, you'll actually see this hourglass-shaped plasma feature. Because, folks, the interstellar environment is nothing like the solar system. The interstellar environment is filamentary. So there's the galactic plane, and the solar apex, that's the direction that the sun is moving with respect to the other stars in the system. And again, the entire interstellar system is all moving toward Deneb. So anyway, that's Plasmascape. I just wanted to briefly show that since we're talking about barycenters and now we're talking about coronal mass ejections right after we show the solar system forecast. So that's what's going on in the solar system at the moment. Thanks for leaving a comment, John. And here is your 1 week forecast. As we approach a new moon, my favorite phase, as it involves sleeping well. Yes, sleeping well. Make sure your sleep chamber is completely pitch black, folks. You know, you can't just wear a blindfold. Your skin has photosensors as well. Your body knows if there's light in your sleep chamber. Sleep better with a completely dark room. Anyway, that's your solar system forecast. That's where things will be in a week. And let's move to coronal mass ejection, since there have been some. We're hoping they're earthly directed, but it doesn't look like it. So those are yesterday's images, and it's actually lacking some images there. Only 55 frames. I don't see anything indicating an Earth-directed coronal mass ejection, and if you think I'm wrong, let us know in the comments. We will not be offended by your comments, although we might be amused by them. And we hope that they are not idiotic. After all, we do read all comments. We just do not respond to all comments. That's another 11 frames from today. Let's take a look at some more comprehensive data here. There are Soho Lasco C2 and C3. We do see multiple CMEs happening there, multiple coronal mass ejections. This one coming out of the southwest looks a little promising. That one could have an earthly directed component there. So this morning around 7:24. Multiple events there happening at the same time. So we're hoping that one has an Earth-directed component. I don't think it does. I think it's multiple events happening at the same time. So let's look at stereo A also here just to give us a little bit of additional data. We show this diagram just to show people how close stereo A is to Earth. It's nowhere near Lagrange 5 way over here or Lagrange 4 way over here. It's barely any. It's only a couple of degrees of angle difference there. So here's stereo A on the left, and then Soho Lasco C3 once again on the right. And do we have data from this morning? Yeah, hoping that's an Earth-directed CME. If so, most of the material will not be earthly directed. It will be mostly off to the southwest. So if that does strike Earth, we can expect that to show up late in the day on the 19th. Late in the day on the 19th, or maybe early in the day on the 20th, but late day 19th would be the best guess. And we're going to come back to filaments here. First, let's show coronal mass ejections from our spectacular imagery from HelioViewer. Yeah, so here's the past 24 hours in composite. Some unfortunate gaps in the data there, but not too bad. And if we zoom in a little bit closer, we'll be able to see any major plasma motions happening on the Earth side. I think there is indeed some material headed this way. Coronal mass ejection here likely to strike Earth. Sometime in between, let's see, late in the day on the 18th, possibly until early in the day on the 20th. So sometime late on June 18th through June 20th, expecting some CME ejecta to strike the Earth magnetosphere there. We can see clear plasma motions here in the 193 angstroms wavelength, and then you can see some ejecta coming out there. That's a fairly stealthy coronal mass ejection. And if you want to read about stealth coronal mass ejections, I'm sure there are articles about those. If we look a little closer here, again, you'll see a bunch of plasma motions here happening on the Earth side. An indication that some of that ejecta is likely headed our way. So that's a good thing. Expecting some CME impacts here late in the day on the 18th through early in the day on the 20th, possible. So exciting times for space weather continue. We're hoping to see the aurora once again at mid-latitudes here in Lehigh Valley, PA. Last but not least, filaments. Yeah, filaments. They're pretty serious. And they are often the source of coronal mass ejections. Of course, we've been naming filaments after living people like this one right here. This one is a huge one, by the way. That's the Cornell West filament, and you can see how gigantic that filament is. That's like 80 Earth diameters in length, at least. So lots of dark absorption features there, known as solar filaments. Those often go blasting off into space, becoming what we call coronal mass ejections. And let's take a look at filaments here in our spectacular 304 plus 193 angstroms wavelengths. So here's a huge filament up here. You can see this like S-shaped feature. That's a gigantic filament. There's also been some crown prominence activity up here. Unfortunately, it's mostly going on the opposite side of the sun there, but you can see this filament kind of making a motion. It's actually orbiting the opposite direction here. So you can see the sun there is moving from left to right. That filament went from right to left around the north heliographic pole. Sadly, we don't have a very good view of that because there's a thing called a star in the way. That pesky star. So we'll also show the equatorial view. Why? Because you're going to see more filaments. Yeah, lots of filaments. And there is the southern hemisphere. I think we've provided some pretty complete imagery of the closest star for today. What would you say? That is some serious stargazing at the Smash News Network least busted name in news. By the way, if you'd like to name filaments after living people, make sure you join us over on Twitter. We're all over the internet at Smash-O-Mash. Just follow the hashtag #NameThatFilament, and you'll find other interesting stuff that has nothing to do with space weather. Or does it? Yeah, big tech. Big tech's involved with space weather. Why? Because of pathetic censorship on YouTube. Yeah. Also pathetic censorship on Twitter, and pathetic censorship on Meta, and pathetic censorship by Apple. You're doing a fine job, big tech. Slow clap for big tech. Doing a fine job, pardon the sarcasm, viewers. All right, so that M-class flare did indeed come from this active region up here, and that remains the most likely place to see large flares. Don't be surprised to see an X-class flare, especially from that northeastern limb. That's the past about 2.5 hours from the GOES 18 SUVI, depicting ionized helium. 304 angstroms is the wavelength. It's part of the extreme ultraviolet spectrum, and let's move to our bonus feature segment. We've got some significant charging hazards here, so some major surface charging happening currently around Central America, Northern South America, the Caribbean, the Gulf of Mexico, Baja California, and the East Pacific. Those surface charging hazards are caused by low-energy electrons, which will tend to build up on the outside of spacecraft, creating a charge on the surface, hence surface charging. The GOES electron flux here showing quite low levels, as you may have come to expect if you're a regular viewer of the channel. There is the 1-year chart of the relativistic electrons. And again, we're at very low levels of electron flux here, as is typical of coronal hole high-speed stream impacts as well as CME impacts, depending on their frequency, I'll just say. The relativistic electron forecast there, you can see it's actually a little bit higher than was expected, and we're expecting the next diamond to be down here. The yellow diamonds are the forecast. The green boxes are the green boxes are the forecast. The yellow diamonds are the observation. Next, we show this diagram of the ionosphere just so that people are familiar with the electromagnetic radiation penetration. For example, the reason that the SDO is in space is because the 304 angstroms wavelength, all the wavelengths from SDO, at least the AIA instrument, like 171 angstroms, 131 angstroms, 304 angstroms, 1600, etc., they're all part of the extreme UV spectrum. And the reason they have to be viewed from space is because they never even make it to the mesosphere. The extreme portion of the ultraviolet spectrum is completely filtered out by the atmosphere by the time it reaches the bottom portion of the thermosphere. Hence, it has to be in space to be able to get the data for the ionized helium and so forth, because it's part of the extreme ultraviolet spectrum. So here is the ionosphere. This is the F layer located at about 300 kilometers of altitude. And yeah, that's what's going on. We've got up to 14 megahertz here. There are some anomalies happening, and if they are not obvious to you, don't worry. We'll show the anomalygram, which makes it a lot more obvious. So that's the previous day in vibrational frequency. Here's the anomaly in megahertz from a 30-day median. If you see a weird place right here over South America, that's because that is where the South Atlantic anomaly is located, Earth's weakest point in its magnetosphere. There's also another weak spot over here near the equatorial West African coast. That's sort of the weakest spot in the whole magnetosphere, right about here. A little band that crosses the Atlantic Ocean. Anyway, mostly low-frequency anomalies showing up here, as you may come to expect from watching the channel regularly, as the ionosphere puffs up, as it gets buffeted by high-speed solar plasma. So quite a bit of low-frequency anomalies popping up there in the northern hemisphere. Not super strong here, so the coronal hole high-speed stream not that crazy. There is the latest image. That's 11:45 Universal Time Anomalygram, and there's the ionogram. Right now, low-frequency anomalies kicking off over the Himalayas and India and Southeast Asia and, of course, the northern Indian Ocean. Total electron content is free electrons up to about 12,500 miles of altitude. It's useful for nearly everybody as it affects GPS communications, and it's useful for space weather because it gives us insight into additional phenomena. And we've got some major anomalies showing up here in the total electron content. You may see some anomalous electrons down here in the Southern Ocean around Antarctica and so on. It's like a little extra miniature Van Allen belt forms down there sometimes, and there you can see some major GPS errors likely in the Southern Ocean and Antarctica. And those were occurring yesterday afternoon Universal Time. They have since subsided. Please pay attention to the time and date stamps there. And it looks like they may be coming around for another round today. That's the total electron content forecast. This is the total electron content anomaly from the 10-day average over just North America. We are seeing some high electron content anomalies here. So those are showing up in places like Florida, the Caribbean, Mexico. Again, that's free electrons from ground level to about 12,500 miles of altitude. Last but not least, we've got the latest SDO intensitygram and magnetogram. Let's check out this sunspot that's been producing all of the recent M-class flaring. All right, it must be this one, because this one looks like it's evaporated here. So interesting. So this is the one that's been producing the flaring. And you can see you don't need big umbrae to produce large flares. What really helps is if you have a huge disparity. So here you've got a really big North Pole umbra, and here you've got kind of a small South Pole umbra. And you can see those deltas there where there's a lot of magnetic shear next to the well-defined umbrae. That is what tends to be associated with large solar flares. And again, we can expect two new named groups up here. Those are legit sunspots, as you can see there. I think they're only alpha class, but let's take a look. Well, that one's beta gamma class. And this one down here, also beta gamma class. So again, solar uptick here, significant solar uptick, and some spectacular imagery. Let's get to meteorology. We don't want the video to be too lengthy. We're starting out with a reason to laugh at people who are claiming that it's a grand solar minimum. Oh, we're going to have a year without a summer, right? Oh, noes. Europe's going to freeze, right? Well, look at the ocean water around Ireland and in the North Sea and so on. It's all anomalously warm. Look at this water off the coast of Ireland. It's 5.6 degrees Fahrenheit above normal for this time of year. What a joke. I mean, what a dud. These are some of the worst forecasts that I've ever seen. The fact that people are still out here claiming that it's a grand solar minimum is just beyond belief. I mean, hi, you've joined a cult. Please leave your cult if you're in the grand solar minimum cult. It's really sad. By the way, I've heard there are some great places to go live in a place called Tora Bora, Afghanistan. I heard that there's a bunch of caves there that are unoccupied. I heard that it's a great place to retire penniless because of coming up with ridiculous forecasts that don't come true and then doubling down on them and attempting to gaslight people with your utter nonsense about space weather and indeed climate. So it's pretty pathetic. If you're in the grand solar minimum cult, please exit stage now. Exit stage whatever. Exit stage bunker trapdoor, please. So there's the North Atlantic, and if you think the NAO, the North Atlantic Oscillation, is shutting down the AMOC, the Atlantic Meridional Overturning whatever circulation, if you think it's shutting down, there it is, the Gulf Stream. It's still warming up Europe. Next, this is depicting sea surface temperature anomaly and currents. By the way, the equatorial Pacific has heated up as well, which is why we're forecasting a longer day. Yeah. So the Earth's rotation's been speeding up, and we think this year it's going to slow back down again. Why? Because of all this water creating a larger equatorial bulge, similar to a figure skater putting out her arms. When she pulls in her arms, she speeds up. When she puts them out, she slows down. The Earth does the same thing as a result of water in the oceans and its temperature. Cold water takes up less space, and of course, frozen water tends to deposit itself at the poles. Anyway, that's the sea surface temperature anomaly for the Pacific. Here's the Southern Ocean. Sea surface temperature anomaly and currents for the Atlantic depicted here. The Atlantic, mostly warm, although there is a bunch of snowmelt coming out of Greenland. And here is the Indian Ocean, pretty average. And here is the Arctic Ocean, anomalously cold. So that's the current situation for sea surface temperatures and currents. Let's take a look at the wind. A strong low continues to loiter south of Australia, rotating clockwise as they do in the southern hemisphere. Two lows in the North Pacific there, hanging out. That's the surface wind scenario for the east. There are the jet streams of the east. There are the jet streams of Europe, Africa, and Central Asia. There are the surface winds of this side of the planet. Surface winds of the Americas depicted here. And there are the jet streams. Still extreme meridional jet stream flow over the northern part of the U.S. Cold air blasting down from Canada, warm air blasting into Canada, warm air blasting out of Canada. North and south-oriented jet streams continue. Next, a satellite view. Another spectacular series of images here from windy.com. Let me just give that a minute to spool up here. It's well worth it. Fantastic imagery there from the windy.com satellite, which is a series of satellites that are stitched together. We've got some extreme weather continuing to strike the Gulf states. Check out that supercell forming over Mississippi. Those are some high cloud tops. And of course, some great contrast created there by the rising sun, which, by the way, is not fake and neither is space. So here's clouds and fog. Now we're showing shortwave radiation, which doesn't care if it's nighttime or daytime. Some pretty violent systems there showing up around Central America. Check out this rapid cloud nucleation. That is serious. But Mississippi is getting pummeled as we speak. More information on that here in a moment. First, our weather.gov map. If your location is lit, head to weather.gov. That is the website of the National Weather Service, weather.gov. We've got not only frost advisories, but we've also got excessive heat warnings. So we've got temperature anomaly forecasts coming. Again, if your location is lit, click your location. Those are too many locations for us to cover. Perhaps we'll consider doing more extreme and detailed meteorology videos in the future. Anyway, there is your current pressure and precipitation forecast based on the 72-hour GFS model. So take heed of all those red areas. A lot of extreme weather here coming to the central and southeastern U.S. Enough said on that. Here is the total accumulated precipitation forecast, because we did show some flooding, some heavy rains expected there for Colorado, Nebraska, and Kansas. Also the Gulf states, Mississippi, Alabama, the Florida Panhandle, large parts of Florida and Georgia. 72-hour GFS total accumulated precipitation forecast in inches is what you're seeing here. Lots of places they're expecting more than 4 inches of rain in the coming 3 days. Last but not least, temperature anomaly. This is in degrees Celsius. Once again, it's a 72-hour GFS temperature anomaly forecast. And there are going to be some wild temperature swings in southern Texas. Check it out, going from 20 degrees below normal to 12 degrees above normal. And again, those are degrees Celsius, which are big degrees. Some wild temperature swings happening there. They're getting Pennsylvania weather in Texas. Pennsylvania, where the temperature is known to swing 80 degrees in a 24-hour period. 3 seasons, all in one day. Next, your lightning mapper. Extreme lightning here. You can see going across Oklahoma, Texas, Arkansas, Louisiana, Mississippi, Alabama, loitering over the Florida panhandle. And let's take a look at a real-time lightning map to see where the current cells are located. And they are some nasty ones, I think. Give that a minute to connect to lightningmaps.org. Next time you hear thunder, check it out. And here's this supercell we were just looking at. Mobile, you are in the crosshairs. There is an extreme storm coming. And keep in mind, folks, the most likely places to see a tornado or hailstones develop would be the northwestern portion of a storm like this. That is the kind of cell that can produce damaging wind and hail. Again, if your location is lit on that weather.gov map, go get your weather warnings. There is a little bit too much of that for us to cover. Perhaps if we ever go full-time, YouTube will consider doing very detailed forecasts. So help us out with that endeavor by pressing like, subscribe, share, etc. Click our links if you're unable or unwilling to open your cobweb-encrusted wallet and become a member of the Smash team or something like that. Visit the website. Help us out with clicks. Go press like on Instagram. Become a patron, etc. All kinds of ways to get involved. We built a massive web ring going back years and years to support our ongoing operation. We're in the process of founding a nonprofit organization, which is a science foundation, which is going to have a main job of explaining the solar sunspot cycles. It's pretty serious. And by the way, when that paper passes peer review, it will be the most important Nature paper in hundreds of years. So become a member of the Smash team at smashomash.com/Smash team. We've already divulged the likely mechanism that underlies the solar sunspot cycles to our gold Smash team members. We also offer them complimentary email addresses. If you'd like, bill@smashomash.com. I think that one's still free. We can hook you up if you become a gold member. So become a gold Smash team member. There's also a silver membership level. Yeah, that'll get you some additional content as well. Thanks to especially our annual paid up Smash team members. Thanks for trusting us for another year of this content. Of course, we do provide additional content as well, which will remain classified to people that don't get involved on our own website. So, okay. You don't want to see the additional content, that's fine. Good luck with that. Here is the radar image, and again, those are some serious storms there. A huge wall of clouds just moving into Alabama as we make the video. And this one here is actually the most concentrated, although it has subsided a little bit there. Just north of Lufkin. Anyway, here's your full 50-state view. There is your lower 48 view as some rain sweeps across Pennsylvania. Those storms are nothing like what is happening in the Gulf states. So here we'll show also clouds and fog, as we're wont to do daily on the channel, providing facts all the way from what's going on from the perspective of the sun, all the way down to space weather, all the way down to Earth weather. There's water vapor for the lower 48. As cold air from Canada comes back into the mid-Atlantic states. Check it out. You can see that cold air blowing down from Canada. Here's your recap. U.S. Doppler radar. So these systems are going to move through quickly in the mid-Atlantic states because they are propelled by a significant impulse of cold, massive air from the maple leaf country. What's it called? From the land of maple syrup and perhaps hosers. cold air blowing across the Great Lakes, once again evidenced there by the clouds and fog view, 3.9 micrometer infrared radiation. And there's water vapor. Again, you can see those various different impulses there. Just remember, folks, that dry air is more massive than moist air at a given temperature and pressure. That should help you forecast the weather. We hope you're able to forecast your weather, and we'd like to thank you for tuning in to the Daily Space Weather. Congratulations on realizing the channel exists. We're frankly surprised, and I'm so surprised at how spooky space is that it's time to head back to the bunker. Oh my God, it's space! Look out, folks! Space! If it wasn't fake, I wouldn't be so scared of it, but I am, so I'm going back to the bunker. Bye! Whoa!